Okay, let us examine these questions because many students make mistake in these questions, which is an MCQ. This question can be tested in the open-ended questions. So I'd like to analyze this question with you. Okay, it says that a skydiver jumps from a plane after falling for some time, this part. He opens his parachute and starts to fall at a slower but constant speed. That means he is still falling, but at a slower but constant speed. Constant speed means same speed. Which of the following graphs shows a change in the skydiver's kinetic energy? So you must understand that when he leaves the plane, right, the kinetic energy is zero. So I do a screen share to show you on this video, what is this situation? As you can see, this is a plane, right? Just to check, is I'm sharing the correct screen. Yes, double check. So as the plane moves, and can you see here, the speed increases because gravity is pulling the parachutist downwards and is in meters per second. So you can see the speed increases and it will reach a terminal velocity, which is the maximum speed the parachutist is falling. So this parachutist is falling at 55 meters per second. If you convert to kilometers per hour, it's about 198 kilometers per hour at this speed. It's still falling. So notice later what happened if the parachute is deployed or parachute open. So at this instant, prepare to deploy parachute. Parachute deploy, I freeze screen. You can see the speed drop slightly, isn't it? And it's slightly to drop. And it's being like dragged upwards because when it open up, right, there's this air resistance that slows down the downward fall. Okay, so like if you are the parachute, you can see that suddenly you are being dragged upwards because the parachute is catching the air. So it decreases to 10, and later it will slow down to 5 meters per second. Okay, 5 meters per second, and the parachutist will actually land at this speed. If I fast forward here, this part, and this is a safe landing at 5 meters per second instead of 55 meters per second. So now we come back to the question earlier here. So you notice at the exit point, kinetic energy is zero, right? So it can be this, right? All possible, right? But cannot be this, right? So just straight away eliminate. Cannot be this one. Because the parachutist sit at the plane, we drop the speed increase. So it's either 1, 2, or 3. Remember the part is this part? When he opened his parachute, right, he falls at a slower speed. That's when kinetic energy drop. So can you see, notice this part, it go up, right? And then it drop. And then it stabilize. So the answer is 3 for this question. Easy to understand? Okay, let's continue the next question earlier. Some students also make this mistake. Okay, question 8. Okay, it's good to draw or annotate by the side because they say P and Q of different masses. So I annotate by these two balls. The orange one is bigger, heavier, and they drop from the same height, 70 meters from the ground. Okay, they ask you which of the following graphs below correctly represents how kinetic energy changes with the distance traveled. Okay, earlier, remember I told you this formula, right? Although it's not tested in PSLE, right? Half mv squared kinetic energy. Okay, half mv squared is equal to the kinetic energy. So from here, you understand that they are of different masses, drop from the same height. So the bigger mass will achieve a greater kinetic energy. So you see which graph, because kinetic energy from here is zero, right? Just like the parachutist. So you start from zero. So cannot be this, right? Cannot be this because this one is not from zero. This one also not from zero, is moving. This one also not from zero. So the only possibility is this. But just to double check, so that means they start from zero speed, right? Kinetic energy. Because one is bigger than the other, so the mass, so P we can reduce is a heavier mass because it achieves greater kinetic energy. So answer is 4. Okay, so these two questions can be modified to be open-ended. So if you modify to open-ended, you must know how to explain. Okay, how to explain for these two questions. So once again, this question on parachutist, take note, when the parachutist leaves the plane, right, he's increasing in speed. So that's why the kinetic energy increase. Up to a speed of, just now we saw the video, right? The parachutist is falling at 55 meters per second. Okay. Although this is not very nice writing. Rewrite again. 55 meters per second, according to the video. It's a very old video, but it's good to appreciate the video. And for student in P6, right, this year they have removed the speed topic because previously the students are required to convert meters per second to kilometers per hour. Okay, go and find out. If I remember correctly, the conversion is, I think it's 198 kilometers per hour. You can find out this. So as he opens the parachute, okay, sometimes I say this can be a open-ended question. So they ask you at which point of the graph did the parachute open? So let's say if I extrapolate, right? So for example, if let's say this point A, right? Okay, point A, point B, point C, point D. At which part of the graph was the parachute open? So you must know that it's B, because when the parachute open, right, the kinetic energy drop. That's when it slow down. Can you see? Let's say this is a certain value. Let's say it's a, just put a generic value, 88. Okay. So this one at a lower value, right? Maybe here, 77. So you can see, you can visualize it drop. And then it stabilized. Stabilized means just now the person is falling down at 5 meters per second. So I wish you all the best in your revision in this topic in the energy conversion. Take care. Stay safe. God bless. Bye.